So is my screen visible?
Yes.
Cool. Oh, 1 second. Okay. So good evening, folks. Welcome to the fifth session of Multiverse of Languages. Till now, we have ventured into different realms and we have seen the likes of JavaScript, Python, Dart, and even Go. But these are relatively newer gods. So today we are going to talk about one of the old gods, which is C++. My name is Ishan Agarwal, and I am from Electrical Part 2. And I, along with Ankur and Sanskar, will be your guide into the realm of high performance meta programming languages. So let's dive in. So before we proceed, I have a very quick question. And the question is, who is the creator of C++? If you know the answer, maybe you can just write it in the chat and we'll see. Who is the creator of C++? You can just maybe try it out. Okay, so Aryan is saying it's Jan Straustrup. Maybe we can expect more answers. So please try it out. Okay, anybody else who would like to shoot a shot? Cool. So I'm seeing a lot of answers which say that it's Björn Strautstrup. So it's right. It is Björn Strautstrup. And so actually, he's the Björn Strautstrup, and I'm sure a lot of people will say that he looks like Rick from the Rick and Morty, and I think I would agree on this, and I will definitely agree that he looks like somebody who can create something like C++. So let's move further. What is C++? C++ is a general purpose programming language which was originally created as an extension of C. To be more specific, it was created to be C with classes. Now, since then, modern day C++ has evolved, and now it has become object oriented, generic, and has functional features. And it can also have low level memory manipulations. And these kind of features help C++ to be used in a variety of things like game development, system engineering, and writing GPU codes, and even writing fast and efficient libraries. And since C++ is fast, it is famous among programmers, especially among the competitive programmer niche for its speed and dynamic standard library. So let's take a look at some of the applications where C++ is used. So the first is game dev. So because of its speed and the OOPS capabilities, C++ is used by almost all the major companies like Rockstar Games to make their game and make complex games. And second, also used in GUI-based applications. So you must have used Adobe Illustrator and Photoshop during your time. And these apps wouldn't have been possible if there was no C++. So C++ helps in performing all the behind the scene GUI operations that happen when you try to edit your photo or maybe mask it out. Adobe Illustrator and Photoshop are based on C++. And also the classic Winamp media player, which from Microsoft, I think I have very fond memories of it, and maybe you will also have if you have used Windows 7 and maybe Windows XP. So it was also based on C++. Next is database management and database management software. So a lot of popular databases like MySQL and PostgreSQL and even MongoDB uses C++ to make their data bases more quick and be able to handle a lot of queries. Fourth is web browsers and email clients. So you must have heard about Mozilla Firefox. So Mozilla Firefox and the Thunderbird email client, which comes in Ubuntu, these are also written on C++. Next is compilers. So a lot of high-level programming languages like Python have the compilers written in C++, and the reason is that C++ is a low-level language and it's very close to hardware and it has a high speed, so it helps in making the compilers also speedy. Other applications include embedded systems, like you have seen your watches, your smart watches, and maybe medical equipments. All of these are programmed using C++. And even high computation libraries involve speed and computations which can be performed quick. and the list goes on. So you must be saying that C++ is used in a variety of things. Okay. So here is a quote from Jan Stroustrup, who is creator of C++, and I think it aptly summarizes the power and the capabilities of C++. So you can read it, and maybe I can read it out. So it says that C makes it easy to shoot yourself in the foot, but C++ makes it harder. But when you do, it blows your whole leg off. So I think that justifies everything that I've said about C++ in relation to all the applications it has. So let's move further. As I've already talked about, and I'll reiterate this, that we won't be going on the basics like C in, C out, how to perform addition, subtraction, because that's known to almost everybody. We'll cover more intricate things which are very useful and will come in handy when you venture through and when you start your journey of C++. So we'll cover some of these streams like string stream and file IO. This will help us in understand how the input and output operations are performed. Like how can we take the input from file, or maybe how we can process strings better. Third, we'll have a look at more the one of the STL containers, which is vector, which is a very powerful container. And if I have to summarize it, it's maybe arrays but more powerful. Then we'll talk about iterators. Iterators helps us in traversing all the containers very smoothly. Just like stacks, queues, sets, and map. And along with that, finally, we'll talk about the OOPs. So we'll learn how we can design a program using classes and objects. And then we will look at how some kind of common errors that we face and how we can debug them. And finally, we move on to the task that we have created for you, and we'll understand how what it is and how you can submit it and learn, understand and share your learning of C++. So let's proceed. First, we'll talk about Stringstream. So before I talk about Stringstream, I would like to tell you about what stream is. So in a program, a stream is basically the flow of data in and out of the program. So what Stringstream does is that it helps us in processing and passing input faster. And it is very similar to the CIN and cout stream. So you must have printed your hello world in C++ and there you have used cout. So similar to that, here we are trying to understand what Stringstream does. So Stringstream allow us to process C++ strings in a very efficient manner. And to be able to use it, we need to make sure that we include the header SS stream here. So we need to ensure that we do it, and therefore then only we can use the Stringstream. And as I already said, it's extremely useful in passing inputs. Now let's take a look at some of the basic methods which are there. So in Stringstream class, the basic methods are clear, str, the insertion operator, and the extraction operator. So the clear method is used to clear the stream, and str is used to get or set the string object. So what happens is that when we try to use Stringstream, so it takes input a string stream and it converts it into a string object. So when we use the str function, we can maybe either get the string object and we can set the string object whose content is present in this string. Then there is the insertion and extraction operator, which can be used to add a string to the string stream object, or maybe read something from the string stream object. Okay, so let's take a look at some of the insertions and extraction operations and how they are done. So first we have done is that we have initialized the SS object of the Stringstream class. So this is done by the first line, which is Stringstream SS. Then what we do is that we do SS and then the insertion operator hello world. So so like how we used to do it in cout. So actually what happens in cout is that when we write cout insertion operator hello world, the hello world string is inserted into the cout stream. So similarly, in place of cout, we have just used the SS, which is a Stringstream object. So we'll use the SS and we'll do this. And this is how we can insert hello world into the string. An alternate way of doing this is that maybe we can call the str function and we can pass the string which we would like to set. So this helps us in inserting the hello world string into the SS string stream. The second is extraction operator. So extraction operator is similar to what what we used to do in CN. So in CN, what we used to do is that we used to take a variable and we used to extract the value for that variable from the CN stream. So similarly, we also do that. So we can use it using the extraction operations. Okay, so what are some of the applications? Some of the applications are that we can use it to count the number of words in a string, and we can also use it to print frequencies of individual word and string. So maybe if a string has a lot of words which are repeating, so we can also use it to efficiently count it. Third, if has a string has has some spaces, so we can remove the spaces from the string using string. And fourth, and a very important application is that it can be used to convert strings to number in C and C++. So I'm sure uh, this is all you have had a lot of theory. So let's dive into the IDE and let's see how this is done hands-on. Okay, so here it is. We are going to use Replit, and we'll give more details about Replit and how to use it later. But as of now, you can just observe me and you can understand how it works. So we have used the bits std c++.h library. So it's a very good library to include. It's a very good way to include almost all the libraries which you will be needing when you will try to code in C++. So I have used this. Then, since I was going to demonstrate SSStream, so I have also included SSStream. So make sure to include SSStream if you want to use the SSStream and the other functions. Okay, so here I have initialized a string str, which is C++ is a general purpose programming language created by Jan Stroustrup. So what I'm going to do is that I've also initialized the string stream object, which is ss, and then using the insertion operator. So what it does is that it is the insertion operator. So the string str gets inserted into the ss stream, and then pass it. I'll pass the string object which was there in the ss into another string s2. So I've used another string s2, and using the str function, I have passed it into the s2, and then we will simply output s2. So let me run the code and let's see what happens. Okay, so as you can see, we were able to successfully pass the string str to s2 using the string stream ss, and you can see the output. It is the same string which we have initialized in str. Okay, cool. So an alternate method of doing this is that the way I showed you in the slide, we will first initialize the string s2, and using the extraction operator, we'll extract the value for s2 from this ss stream, and then we'll simply out it. Let me run the code quickly so that you can see that it outputs the same thing. Okay, so here's one interesting thing that I forgot to tell you. So what happens is that when we try to use extraction operator, it only takes one object out of the string object which is created for the whole string. So when you will use this kind of way, so you will only get the first part, which is the first word of the whole string. And I can show you this a lot better from this following example. One second. Okay, so what I've done is that I've initialized a string str2, and I've initialized it with today's date, so which is 10 to 2022. So I've also initialized this ss1 string stream object. What I do is that through the insertion operator, I will successfully insert str2's value to ss1, and then using the extraction operator, I'll again extract the one object out of the ss1 and string object, and then I'll extract it to str2. So let's run. First, I will uncomment this code and let's see what happens. What is going to be the value of str2? Okay, so as you can see, it took out the first word, which is 10, and uh, okay, now I'll just uncomment this part, and what we have done is that we have again using the extraction operator, taking out one string object from the ss1, and we'll give it to the str2, and we'll print str2 again. So let's see what happens this time. So as you can see, this time, because the 10th word was already extracted, we took out the 0 to part of the whole string, and this could be seen from here. Okay, so we have understood the basics of the string stream. Let's take a look at some of the applications. So the first application is that we can use it to count words in a string. So I'll tell you how we can do it.
Ishan, can you please increase
Sure.
the font size?
Huh?
Font size.
Oh, sure. I'm sorry. Is it visible now? Okay, I'll continue. I'm sure it is visible now. So I've okay, so where I was. Application one, how we'll count the words in a string. So what we have done is that we have already had the string str, which was C++ is a general purpose programming language created by Jan Stroustrup. So what we'll do is that we'll use put it into the SS string stream object, and then we'll also initialize a string word. This will be used to store the individual words which will come out from the string. Now we initialize a count variable which is of type int and it is set to 0. And then using the while loop, we'll count the number of words which happen. So the what happens is that this while loop will continue while the word is not empty and it's able to extract something from the SS string object, and it will terminate when the word will come out empty, which basically means that there would be no object left in SS. So let me just run this code quickly and we can see how it goes. Okay, so as you can see, our string had C++ is a general purpose language. It had almost around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has all 10 words. So it got the 10 words. Cool. So we understood how we can count words from a string using Stringstream. We'll move into the next application. Next application is we can use it to divide all the words from a string. So what we have done is that we have initialized a string 10. This will store the words on each iteration. And similar to what we did above, we have a strm string stream object, which will take the string str, which we have initialized above. And we'll follow the same loop. So as I have already told you, this loop will function while there is some object which can be extracted from strstm by tmp. So when tmp will get empty, this loop will terminate. So let me run the code and tell you how we'll able to divide all the words into a string. Okay, so as you can see, we were successfully able to divide all the words in the string. Cool. Let's move on to the next application. It is to remove space from a string. So as you can see, I'll move to the string. Our original string had space between C++ and S, and you can see the spaces, right? So what we'll do is that we'll use the string stream to remove the space. Doing the similar procedure, we initialize the string stream object. We initialize the temporary string. Using the insertion operator, we take the string and put it to the ss2 object. Then we make a string. Then we make the string empty. So basically, we want to what we'll do is that using the above application, in which we divided the words, we'll simply add the words which were divided and into the string without any spaces. So I'll show you how this is done. So in this loop, it is going the same. So it will terminate only when temp will be empty. So by the time it's running, str will append the temp word, which is the individual word, into the string. So let me show you how the modified string is. Okay, so as you can see, let me make it a little bit more clear. So from here to till here, there is no space, and we have literally taken every space out of the string. Cool. So we understood this. Let's move on to the next application and a very important application. So we can use string stream to convert the string into a num and vice versa. So let me show you how. So as you can see, we have initialized a string s. It is 1927534. It's a basic, it's a random number which I've taken. And similarly, I've initialized the object from the class string stream. I have also initialized an integer x, which is 0. And using the extraction operator, what I'll do is, since this is a one word, I'll use the extraction operator, and from the stream, I will get the number which was originally string into the variable which is integer in type. And let me quickly run the code and see that now it will be a number. Cool. So as you can see, the value of x has now become 1927354. So this can be easily used to convert any string into number. And we can do this vice versa. And I'll leave this as an exercise. There's one more application is that we can print frequency of words. But this application involves map and also iterator. So I think it would be best if we cover this at the last. So I'll maybe leave this function in the file so you can explore and understand this application too. It's very easy. It just uses a map and iterator, which we'll cover later. Cool. So we have covered the string stream, and we have almost covered all the applications here. If you have any doubt, maybe you can post it in the chat box. Yeah, we can do it, convert into a long, I think. It shouldn't be any problem. And as I have told you that we can do it from end to string and string to end. So it can be done both ways. I just showed you from one, and you can take inspiration from that and maybe try out the other way. Are there any questions? Okay, so I don't see any questions. So let's move further. Cool. So now we'll cover file input output. So taking input and maybe taking out, getting the output to a file is a very important part of C++. A lot of times we want to take the input and file maybe during cooperative programming when we have the test cases in another file, or maybe when we want to input all the data that is generated through our program into another file. And the file can be of any form. Maybe it can be form of a text, maybe it can be form of binary. So it depends on us that what we can do. So we'll try to demystify that. And I'm sure a lot of people would have said that file handling is very tough, but it isn't. And I'll help you in making it very easy. So this is a meme which basically describes the situation. So let's move further. So I'll brief you on this. So there are three stream classes which are there. They are off stream, F stream, and F stream. So off stream is used to write on files. So we will. I've already told you what stream is, and like the SS stream. So here we use off stream, F stream, and F stream, and these are used to write on files. Now if stream can be used to read on files. So when we want to read from a file, we'll use the if stream to read. Now f stream can do both, and it depends on what we kind of specify for it. So maybe so it can also read and it can write from or to a file. Now before we proceed, one thing I would like to mention, it's very important that before we do any kind of operation which involves reading or writing, a file must be opened. So this is a very important part, that we need to understand that a file must be opened, and so just be careful about that. And then we'll take a look at some of the basic operations in the file handling. So these operations are open, read, write, and close. So as you can just see it, the open is used to read and open a file, and read is used to read data. Similarly, write is used to write new data, and close is used to closing a file. But now these two, like I mean, you don't understand the application just by looking at the methods, right? So we'll take a look at them individually. So how do we open a file? So the standard syntax for opening function, for the open function, which can be a member of stream of stream. As I told you that we need to open a file before we kind of do any operation. So it's like this. So we use void open, and it's very confusing, and I'm sure a lot of people will get scared of it, but don't worry, it's very simple. Let's move on to the example and we'll see. So what we have done is that we have initialized a new file object from the fstream class, and we'll call the open method, the method I talked about, open, which is used to open a file. So we'll put the path of the file that we would like to open. For example, I have a file which names newfile.txt. So I will put the path of it so that it could be open. And then here is the mode. I'll talk about mode in the next slide. So for now, you can just understand that it's just that. Okay, this is also one of the examples. Here we have used a different modes, and I'll make you understand what modes are and what does iOS out and iOS app mean. So I'll make you understand it in the next slide. Okay, so let's move further. So what are modes? So modes kind of specify what kind of operation that we'll do with a file. So you can see the member constants, which are in, out, binary, 8, app, and trunk. So in stand for inputs, and it is used when we want to, when the internal stream buffer supports input operation, and it is used for when we want to open the file for reading. Similarly, out is for when we want to open the file for writing. Binary, most of the time we want to write the and make our operations in text, but sometimes if we want to use binary, maybe we can use this mode. So if we add iOS binary in this second part, in this part, so we can be able to perform all the operations like read and write in binary. Then there's 8, which is at and the output position starts at the end of the file. Then there is app, which is append. So what it does is that generally when we try to use the out mode, so it rewrites the new content that we will write on it with the existing content. So basically the content which was present before we were writing is lost. So what we can do is that we can specify this app mode. So what it will do is that it will append all the existing content from which was existing content to the content which was present in the file before it was opened. And similarly, this trunk, it can be used so that any content that existed in the file can be discarded. Okay, so let's take a look at some of the default open modes. So as I told you, stream is used to read. So read from files. So it has the default iOS in. Offstream is used to write. So iOS out is its default. Fstream, as I told you, it can work both ways. So we can specify whether it's iOS in, iOS out. Also, a lot of times maybe we want to do a two kind of operation. Maybe we want to write, and maybe we want to specifically write in binary format. So we can do this. We can combine different modes using bitwise operator, which has this symbol. So you can see one of the example. This example is that I've taken the new file, as I've shown you here. So this new file is the object of fstream. So we'll use out open method, and then we'll specify the path of the file that we are going to use. And then iOS out means that we are going to write in this file, and iOS app means that we are going to append the new content that we are going to write against the existing content. Next is closing a file. So we have opened a file, we have performed our operations. What's next? So as soon as the program terminates, all the open files are automatically closed, but it's always a better practice to use close function to close the open files after use. And it can be done using this. So we simply call the close method for the object that we are going to use. Cool. Now let's take a look at writing and reading from a text file. So text files generally don't have the iOS binary flag. That means that the operations are not in binary. So the reading and writing operations can be done simply the way we used to do with cout and cin. So if you remembered what I taught you when we were doing Stringstreams, so it's similar like that. If you want to write to a text file, we can use the insertion operator, and instead of the cout, we'll just add the offstream or the fstream object. Or maybe you must have used put, so put can also be used. So using put, we can try to write to a text file. Then comes reading from a text file. So what the reading can be done in a similar manner. What we can do is that we can use extraction operator, which is this. And instead of the CN, which we used to do with this, we'll use the stream or the stream object, which we have initialized. And maybe you can also use getLike. Okay, so before this, let's move to idea and let's understand what we have done till now. Okay. Cool. So as I've already told you, I've added bits, stdc++.h, and I've also, one thing I forgot to mention, we also need to include the stream dot include header. So it's very important that we include it. If we don't, then we won't be able to do the file handling because all the classes are stored in this header. Okay. So let me show you what we're doing. So I've written a basic program in this we string input and age. I'm taking the input for your name and for your age, and I'm going to write it into the out file, which I have initialized as input.txt. So how I'm going to do is that first I created an out file object from the offstream class. Then I use the open method. As you can see, this is the open method, and I specified whether what is the path of the file where I'm going to write. So this is the file. As you can see, it's as of now is empty. Okay, so it's empty, and now what we'll do is that using the insertion operator, this is insertion operator, we'll try to write it the input and the age into the file, and then we'll close it. So let's run it and see what happens. Okay, so it's asking me for my name. So let me write my name. My name is Ishan. My age is 20. Okay, so I think it's done. So let's see that whether the data we have provided is stored in the file or not. So, okay, before we operated the program, it was empty, but now Ishan and 20 has been successfully stored in the file. So as you can see, very easily we got data from our program into the input.txt. Similar, I'll show you how we can read from a file. So we can do it through this. Okay. So, just like how I did the offstream out file, so I'm making an in file object from the stream class. Then I'll specify the kind of the file where I want to take input from. So since I had data here and so I will take input.txt. This is basically to make the file to make the commands more readable. Then I'll use the extraction operator, and using extraction operator, I'll take the extraction. So as I told you, it's Stringstream. So when we take a file, it only takes the one object out of it. So when we'll use the extraction operator, the file will only get the Ishan once, and then we'll have to again use the infile extraction operator input to output the age. So let me quickly show you how this is going to happen, and we'll have the age and the number which we had there in the input.txt printed here. Okay, so it's again asking me for my name because I did not uncomment that code. Anyways, I'll write 21 this time. Okay, so as you can see, as I already told you that when we don't specify iOS app, so it overrides the content which was there present with the existing content. So since I wrote the age as 21 this time, so this time it over the whole file was overwritten, and now it's Ishan 21. And similarly, when it was read, we got Ishan in 21, and through two operations of extraction, we got Ishan in 21. We can also I'll also demonstrate how we can use the iOS app to append the data. So I'll append one more information into the file, and we'll see that the existing data, which was Ishan and 21, does not get deleted. Okay, let me run it. Okay, so it's asking me for a name. Let's take a different name. So I'll take Aditya just for the sake of example, and I'll mention the age as 19. Okay, but since we only had two extraction operations, so we'll see Ishan and 21. Well, let's check in the input file and see what happens. So you can see it did not override. So the old content is already there, and we also got successfully wrote the new content which we wanted to write in the file. So you can see it. Good. So okay, and now as I told you, as I have already told that we use the while loop to get data from a file. We can do a similar kind of thing here too. So now I have four lines, which is Ishan, 21, Aditya, 19. So how can I just get all the lines? So I'll use this. So what is this? Line.eof. So what eof method is that what it does, that it checks that whether we have reached the end of the file. End of the file means that we have the point when there is no content present in the file after this. So the loop will run while we have not reached the end of the file. And till the time the loop is running, we'll extract a character from it and we'll output the character. So let me just run this code quickly and see what happens. Okay, it's again asking me for name. Cool. I think it would be good if I provide one name. So I'll provide Yash this time. And let me put the age to 22. Okay, so let's see. So as you can see, since I used the character, so it got all the content from the file character by character, and therefore there was no space in this. So, but we still got the data, Isha 21, Aditya 19, Yash 22, and we also were able to get it from the file. Now, one thing we can do is that we can use this. We can do similar thing with the using the insert extraction operator. So what we did in Stringstream will do a similar thing like here. So this loop will run while we can extract something from the in-file object, and it will output the string that we extract. So let me run the code real quickly. Let me provide data. So let me say it's Akash and it's 24. So as you can see, we were successfully able to take out all the data from the file and the manner it, in the which it's stored. Now let's move further. So so for binary files, reading and writing data through the insertion and extraction operator is not very efficient. So there are two members which were specifically designed for this, which is read and write, and their prototypes are like this. So write uses one second a memory block in a size. Similarly, read uses a memory block in a size. So what is a memory block? Memory block is a pointer to char. It kind of represents the address of the array of bytes, the array of bytes where the data elements are stored. And size is basically the block which we are going to write or read from the file. So size parameter is the integer value which specify the number of characters we'll read. Okay. Before we proceed further, I think it should be good to mention some of the functions which are associated with the stream. So these functions are seekg, seekp, delg, and delp. So seekg is used to set the current get position in stream. So when we are using a stream, if we want to read from a specific position, we can use seekg. And if we are trying to write a data, maybe we can use seekp. So seekp will set the current position to the current put position. So by put position, it means the point where from where we would like to read or write the content. Now seekg and seekp are used to set the get and put position. Now if we want to just fetch the position which is there, so we can use telg and telp function. So what telg does is that it returns the current get position in stream. So maybe if we are reading a data and we want to check out how much we have done and how much we are across. So we can use telg. So it will tell us the current get position in the stream. and we can use telp. So telp will help us know that how much data we have written. Maybe if we are writing some blocks of characters, and if you want to check where we are, so we can use telp to return it. So it's very simple to remember. Seek is when we are trying to set, tell is when you're trying to fetch something, and now G is for get and P is for put. So you can just understand it that seek G is used to set the current get, and seek P is set current put. Similarly, there are some other functions which can be used to check the state of stream. These are bad, fail, UF, and good. So bad and fail returns whether the reading or writing operation fails or not. Or fail also has does the same as bad, but it also tells us whether there was a format error or not. EOF. So as I've already told you what EOF is. So what EOF does is that it tells us whether a file has reached the end of not. So it can be very useful when we are trying to read from a file, because it can be used in the while loop. And as I've already demonstrated, we can successfully read. And then the good is basically it returns false in all the cases of bad and fail, which in the bad and fail. So now let me show the code real quick. So this is a way to read from a binary file. So I've demonstrated how we can read from a binary file. So what we do is that we have a binary file object from isstream class. Then again the same open method. This time we specified the binary file that we wanted, which is this. And since we are reading it, so we'll specify iOS in. And since we are performing all the operations in binary, it's iOS binary. Now we are going to use the seekg. So I've already told you what seekg is. Seek means that it's going to set, and g is get. So it's going to set the current get position to the end of the file. So using this, we have set the current get position to the end of the file, and then we'll initialize the integer length, and what using the telg function. So telg function is that it will return the position. The first we set the position to the end of the file, and then using telg we get the will return what the position actually is. And then we will again set the position to the beginning of file. So what we are basically trying to do is that we are going now first we are trying to compute the length of the binary file. This will be helpful in running the loop so that we could efficiently read. And then after doing all the operations which we did in these two lines, we set the get function because we are reading to beginning again, and we do this by iOS PAG. Now this is simple loop where the telg, as I told you, it tells the current get position. So it just check whether we have reached the length of not, which means that we have reached the end of the binary file or not. So while we haven't, it will take an integer x, and it will read it through the read function. So I have told you how it is done. It is a pointer char to x, and this is the size of the variable, which is int, and then we'll print it. So I'm not going to run this code, and maybe you can check this out. And similarly, you can also check how we can write into a binary file. So it's very easy. Are there any questions as of now? So I'll take a 1 minute break. So for the meanwhile, you can just uh, tell some questions, and we'll see how we can do that. Okay, so I think there are no questions. If there are, so maybe please do write them in the chat box, and my friends will help you in resolving them. So, okay, let's move on to the STL container. So now we are going to talk about vectors. And if I have to summarize this in some words, it is basically arrays, but more powerful. So you must have used arrays in C, and you know its capabilities, but now we are going to learn about vectors, and it's very powerful, and it kind of does all the things which the arrays can do. So here is a simple meme which tells you what array is. Okay, so let's move. So arrays are kind of dynamic arrays. So they have the ability to resize itself. So If you remember, the arrays used to have fixed size, and we can't initial set the size on the runtime. But with vectors, we can do this because it automatically take care of the storage of the container. Also, the elements which are stored in the vectors are stored in contiguous storage, so they can be easily accessed and traversed using iterators. Okay, let's move further. What are the important functions in vector? So the some of the important functions are size, pushback, popback. So I'll just briefly explain them, and I'm sure that it will look boring if I don't explain them on code. So I'll code it out, and we'll see hands-on what happens. So size is, as always, it's used to return the size of the vector. Pushback. So what we do is that pushback allows us to push elements into vector from the back. So in a vector, basically all the elements are inserted from the back. So we do it by pushback. Popback, similar to what we did in pushback, we inserted it. Now we are going to use popback, and it's going to remove the element, or maybe, and if I have to say it in the terms of vector, pop it from the back. Then there's insert. Insert is a function which is used to insert new elements, especially at a specified position. We have empty. Empty tells us whether the STL container, which is vector here, is empty or not. Front and back. Front tells us it gives a reference of the first element in the vector, and back gives the reference of the last element in the vector. Similarly, erase. So by the word erase, you can just understand that we can use it to remove elements from container from a specified position to range, and clear is used to remove all the elements in the vector. So before moving further, let's take a look at them in the IDE. All right. So interesting part is how do we initialize vectors? So let me tell you how it is done. So we initialize a vector using this. So vector, then in this part, we'll tell the type of the elements we are going to store. So in this case, I'm trying to store int. So we'll use int, and I've given a name VC. So it's vector int VC. So I've initialized the vector successfully. Okay. So what we can do as of now is that let me just run this piece of code and explain this. So we are going to use vec.empty. So vc.empty, I've already told you what an empty function is. It tells us whether the vector, which in our case is vc, is empty or not. So I have a simple if and else condition. If the vector is not empty, we are going to return the size of vector. Else, if the vector is going to be empty, it's just going to output that vec is empty. Just let me just run it, and let's see what happens. Okay, so initially I had not pushed anything into the vector, so it's going to be empty. So using the if else, since the vector was empty and we had put this condition, so we got into the else part of the code and returned vector vec is empty. Now what I'm going to do is that I'm going to push sub elements into vector. So this can be done in this way, that vector dot pushback and the element that you would like to push into it. So in this case, I would like to add 8 into it. And remember, if I told you that when we use pushback, the elements get added into the back by the back. So you can see it. Okay. Now, can anybody tell me what is going to happen if I run the code? Please write it in the chat, and maybe we can see. Anybody else? Right. So I'm getting a lot of answers for 3. So it is correct. Let me run the code and show you. So it is 3 since we pushed 3 elements, which were 8, 10, and 15. So the size of vector was 3. Now I have already told you that in a vector we do not have to explicitly mention the size of the vector, but we can also do this, and it is initialized using this. So what we do is that we put the size that we want to have in the brackets. So it is done in this manner. So okay, let me do this very simple change, and let's see what happens. Now, can anybody tell me what is going to happen if I run the code? Okay, so somebody is saying 0. I've got an answer 10. I'm looking for some answers. Okay, I've got 10, another 10, 40. I'm not sure how that's going to happen. Okay, 10. So I'm seeing a couple of answers and they are saying 10. So let's run the code and see what happens. So the folks who answered 10 were right. So the answer is 10 because we have specifically given that the vector is going to have a size 10. Cool. Okay, now I'll demonstrate what pop back is. So what I did that I already had pushback 8 and 10 and 15 in back. Now I'll use pop back. So pop back is used to pop the element from the back. So we popped it up. Now let's see what happens and what is going to be the size of the vector. Let's run the code. I think it's obvious since we have popped one element out of it. So the size should be 2. Oh, 2. So cool. We understood how it is going to happen. Let me uncomment this part too. Okay, and now we'll see how the front and back VC dot front and VC dot back works. So what it does is that front gives us the reference of first element from the start, and the back gives us the last element. Let me just quickly run this, and as you can see this, we first pushed 8, and then we in the last we have pushed 6. So we'll see this when we run. Okay, so the front element was 8. Okay, right. I forgot this. So we already also popped back the last element. So the element which is now at the last position is 9. So the back element is going to be 9 and the front element is going to be 8. Cool. So now let's move on. Let's see how we can traverse a vector. So a very simple way to traverse is that we can use a for loop and we initialize the entire equals 0. And then we also see till when it will run. So it will run till vec dot size. So vec dot size is used to get the size of the vector. So since we need to traverse the vector, we'll use this. And similar to what we did in array, we get the ith element of the vector using this. So let me run this and quickly show you. Okay, so as you can see, since there were 4 elements stored, so they are like this. And I've also mentioned I, which is the position of the element in the vector in the output. Now let's move on to iterators. So before we cover next part of it, we'll move on to iterators. Okay. So what are iterators? Iterators allow us to traverse to containers like vector map very smoothly. And this basic syntax is that here there's the container type, which can be which is the container type. Like if I'm going to traverse it through the vector, which is of int. So I'm in this I'm in this part, I'm going to write vector int and then these two, and then I'll have the iterator. And I can also use the const iterators. So container type, as I've already told you, it is the parameter. It tells us about the type of the container for which the iterator is declared. So some of the common operations are begin, end, advance, next, and previous. So begin is used to return the beginning position of container. End is used to return the position which is after the actual end of the container. So if the end of the container is at 9, so it will return the position which is theoretically after it. Advance. So we can also use advance. Advance is used to customly increment the iterator position to the specified number, which can be mentioned in the argument. Next is just what like we used to do in plus plus. So it will increment the iterator by 1, and previous can be used to it's just like minus minus. So we'll decrement the iterator by 1. Okay. Let's take a look at some of the iterators and the functions which are there in vector. So we use begin, end, and r begin and r end. So you know what begin is, you know what end is. So begin returns the point, an iterator pointing to the first element. End returns an iterator pointing to the theoretical element which follows the last. R begin is a very interesting thing. So it returns a reverse iterator. So what this reverse iterator is that it will point to the last element in the vector, and it can only move from last to the first element. So it will move in the reverse order, in a reverse fashion. Similarly to what R begin is, there's R end. So R end is a reverse iterator and points to the theoretical element which is preceding the first element. So mind you, it's the theoretical element preceding the first element, just like what was there in the end. So the theoretical element was after the last element. Here the theoretical element is preceding the first element, and it also goes in the reverse fashion. Let me just show you quick. So since we were using a vector of int type, the way to declare it is using this. So this is how we declared a pointer with iterator, which is a name, which has name pointer, and this is a type. Now, if we these are very successful in iteration, so we can also iterate using iterator, or we could traverse the vectors through iterator. I'll just cover this in the next slide. So what are the benefits and use of iterator? It is convenience in programming. You need not to be worried about the size of container. You can just simply use begin and end. So it will specify the starting position and the position which is following the end element. Then there's code reusability. So as I have told you that iterators can be used for map and vectors alike. So just by changing some just by making some small changes, it can be used for all of them. And iterators provide us the ability to dynamically add or remove elements. So let me just show you how you can iterate and traverse a vector using iterator. So this is done in this manner. So we have initialized the pointer, which is an iterator, to vector.begin, which points to the first element, and vector.end, which is the element following this. So I'll quickly run this. So as you can see, very simply, and this is a very good way to traverse through an vector, and we got all the elements which were present in there. Now let's move on. Now, since if you are working with C++ iterators, you can just be cool like Saltway and show your friends how you can traverse through vectors. Now, reach-based loops. Now, I'm sure if you have ever used loop, and you must have because you guys are learning C, then you must have used variables like ing. And I wouldn't disagree if some people told me that it's the law that we have to use ing when we are trying to use a for loop. So, but now I'm going to introduce you to something which is called range-based loops. So it has defined for loops for the STL. So the basic syntax is that you have the for, and here we declare here is the range declaration. It kind of gives us what is the type of data that we are going to iterate over, and here's the range expression which tells us the data on which we are going to iterate, and here's this code which we want to write in. So this is the use. We first initialized an array which is int num of size 3, and it has 1 2 3 in it, and we use the loop, range-based loop. So here we have written int var, which basically means that we are going to use the var which is of type int to traverse to the num, and num tells us that we are going to traverse through this and use this. Okay, now a very cool way auto gives us, or the range-based loops gives us a very cool way to traverse through vectors. So we don't have to write this much code. A very simple way is to use this. So let me just show you quickly. So as you can see, we were successfully able to get all the elements out of the vector using this very simple code. Okay, moving further, auto. So you must have used int, char, and bool, and sometimes you get tired and you just want that maybe C++ can infer the type of data that I'm going to store. So don't worry, we have auto to your rescue. So we use auto, and auto can be very helpful, and auto is especially helpful when we want to we are tired of writing very big words like this. So if you for example you would like to initialize a pointer, so we don't have to write a vector, int, iterator, etc. Just for this we can simply use auto and do this. So let me show you one example where I'm simply using auto. So I've used this auto PTR, and I don't have to tell what the vector container type is. And I'm using auto PTR. It will automatically infer from it, and let me run this of the code, and we can see this. Now we are let me before this, let me tell you that a star is used to get access the element which is present at the position of iterator. So as you can see, it's very simple, and we were successfully able to get it. Okay, let me quickly show you some of the uses of R begin and Rn. So what we'll do is that we'll try to sort the array using iterator. As of now, you can see array is not, the vector is not sorted. I'm sorry, it's at 8, 10, 15, 9, 6. So obviously not sorted. First, we'll sort it in normal manner, and we'll output this. So let me show you how the output is coming. Just a second. So I've initialized the iterator, and let me run the code, and it will sort it. Code is taking some time to run, but don't worry, it's going to take output. So as you can see now, the vector, all the elements in the vector are now sorted. So it's 6, 8, 9, 10, 15. With a simple change, R begin and R end. Using these iterator, we can sort this in a descending order. So let me quickly run this too. Okay, so now you can see that the elements are now successfully sorted in a decreasing order. Cool. So we have understood the power of auto, and now I'll let Sanskar take over from here.
Is my screen visible? Okay. So after vectors, let's move on to stacks, which is the next data structure. So stacks follow a LIFO type of working, which is last in, first out. So a new element is added at one end of the stack, which is called the top of the stack, and elements are also removed from that end itself. So let's see some important functions on stacks. Empty is the first function. It returns whether the stack is empty or not. The size function returns the size of the stack. Top function returns the topmost element of the stack. To push elements into the stack, you have to just use the push function and pass it the argument which you want to push. And pop function deletes the topmost element of the stack. It deletes the topmost element of the stack because a stack follows LIFO, which is last in, first out. So the topmost element will be popped first. So let's check all these in the IDE. This is how I declare a stack int and just the variable name. Here I've pushed 5 and 8 into the stack. So 5 is pushed first, and then 8 is pushed on top of 5. Check the empty function, we can just do a simple if-else case. If what I'm doing here is stack is if stk.empty, then I'm printing that the stack is empty, else I'm printing that the stack is not empty. So obviously it will give that the stack is not empty because there's 5 and 8 in the stack. The stack is not empty. To check the stack size, we can just use the size function as I mentioned. And let's run it and see. Yeah, so it gives the stack size is 2 because there's 5 and 8 in the stack. Now let's see how we can print all the elements of a stack, or how you can traverse through a stack from the top to the bottom using a while loop. So what I'm doing here is till the stack is not empty, I'm till the stack when the stack is not empty, I'm printing the topmost element, and then I'm popping it. So the topmost element will be deleted, and then I'm continuously doing this until the stack is empty, after which I'm exiting the while loop. So in this way, you can print all the elements of the stack from top to bottom. Yeah, so 8 is printed first and then 5 because 8 was pushed on top of 5. Let's move to the next data structure, which is queues. This follows the FIFO type of working, which is first in, first out. So the elements are added at the back of the queue by using the enqueue function, and elements are inserted at the back of the queue and deleted from the front because it follows a FIFO working. Here also the functions are similar as before. Empty and size are the same as before. Empty returns whether the queue is empty or not. Size returns the size of the queue. Front returns the reference to the first element of the queue, and back returns the reference to the last element of the queue. Push and pop are similar as before, but except the thing that pop deletes the first element of the queue because a queue follows FIFO working. So let's check how it works. So here I've pushed 5, 8, and 3 into the queue. 8 is pushed behind 5 and 3 is pushed behind 8. And here also we can just check if the queue is empty or not by using the empty function. Since it has 3 elements, it should print that the queue is not empty. Yeah. Okay, so now we can also get the size of the queue using queue.size and the frontmost element and the last element. So can you all write in the chat what do you think the output for these two will be? The queue.front and queue.back. The output for these two. Okay, someone is saying 3 and 5. Someone is saying 5 and 3. 3 and 5. Okay, let's run and see. Yeah, it should be 5 and 3, right? Not 3 and 5 because the frontmost element is 5 because that is pushed into the queue first, and 3 is pushed last. So 3 will be at the back. So that's why it's 5 and 3, not 3 and 5. Let's we can also traverse a queue in a similar way as we did for stacks using a while loop. And I'm running the while loop until the queue is not empty. And each time I'm printing queue.front, which is the frontmost element in the queue, and then I'm popping it. And when the queue becomes empty, I'm exiting the while loop. So in this way, all the elements will be printed from front to back. So now can you tell me what will be the order of printing for this while loop? What will be the output? 583. Yeah. Akash got it first. So yeah, it should be 583. Let's move to the next data structure, which is sets. So sets are also a type of associative containers in which each element has to be unique. This is important. Remember this. Each element in a set has to be unique, and the values stored in a set are in a sorted order. So a set stores all the values in a sorted order, and all the elements in it are unique. Remember that. Here also, empty and size are the same as before. Insert is used to insert an element n into the set. Begin and end, as Ishan explained, these are iterators, which begin returns an iterator to the first element in the set, and end returns an iterator to the theoretical element that follows the last element in the set. Not the last element in the set, the theoretical element that follows the last element in the set. And s dot, okay, let's check these functions first. Here I've made a set which is of type int, and I've inserted all this into the set, and I'm checking if the set is empty or not using the empty function. Yeah, set is not empty, obviously. So now st.size. So if I'm inserting all this into the set, what do you think the output of this should be? What's the size of, how many elements are there in this set? Some people are saying 5, some people are saying 6. Okay. I think Ishat Gupta has said the right answer first. It is 5. And the reason for that. Yeah, it is 5 because, as I mentioned, each element in a set will be unique. And here I've inserted 4 twice. But in the set, there'll be 4 only once. So the 5 elements in the set are 4, 7, 3, 10, and 1. That's it. There's only one 4. That's why it's 5 and not 6. So that was the important thing. Yeah, again, I've explained begin and end. So we can now print all the elements of a set using, first I'll show using the iterator, this whole syntax thing. And then after that, we'll do it also using auto keyword, as Ishan has already explained. So I've just made an iterator ITR variable, which is an iterator of type set int. And I'm iterating from st.begin, and I'm coming out when it is equal to st.end. And I'm printing the value of each location. So in this way, you can print all the values of the set. One, 3, 4, 7, 10. 4 is only present once. And this is also in the sorted order. See, I didn't do anything specifically to sort it or anything, but it's stored in a set by default in the ascending order. So 1, 3, 4, 7, 10. Now the next function is find and erase. So what find does is it returns an iterator to the element with the value x. And if x is not present in the set, it returns st.end. Okay, and erase is a function which takes in an iterator as the argument, and it deletes that value which the iterator is pointing to. So if I want to do this for 10, what I'm doing is if st.find is equal to st.end, that means if 10 is not present in the set, then I'm printing that the element is not present. And if it is present, then I'm erasing that from the set. If it is present, then st.erase of st.find of 10. And this is an iterator. Okay, so this should erase 10. I mean, nothing will be printed, I guess, because, yeah, this is not printed. That means it was present and this was carried out. Now we can traverse using the auto keyword. As you already know, auto keyword is used to deduce the data type automatically. And just like how we have done before, we can traverse through the whole set like this. It's similar to what has been explained before. And now we can run and see if 10 is still present in the set or not. Yeah, it's not there anymore. If you want to, this is also very useful if you want to check if an element is present in the set or not. So like you can just keep this part, and like if I check for 18, then it should in that the element is not present. So you can use this to check if an element is present in the set or not. Yeah. Now let's move on to the next functions, which are lower bound and upper bound. Lower bound returns an iterator to the first element in the set, which is greater than or equal to x. And if that's not present, then it returns s.end. And upper bound is exactly the same as lower bound. The only difference is that it's greater than x. Here it's greater than or equal to x. So let's check it here. I've created two iterators, it1 and it2, using the auto keyword, obviously. it1 is st.lower bound of 3 and it2 is st.upper bound of 3. Okay, so you know what these two functions do, and I've also written it here. And if it1 is not equal to st.end, then I'm printing the value of the lower bound. I'm using the star, so it'll be the value, which is the lower bound of 3. And here also I'm printing the upper bound of 3. And if it's not present, I'm just writing that statement. So in this case, in just a second. Yeah. So in this set, what do you think the lower bound and upper bound of 3 is going to be? You can write it in the chat, the output of this part. Like basically the lower bound of 3 and the upper bound of 3. Three and 4. Okay. Any other answers? Only one answer. Priyansh, no, it won't return all the elements after that. It's just, it points only to the first element, which is greater than or equal to 3, and only the first element, which is greater than 3. So it'll only be one value and not all the remaining elements of the set. So yeah, the answer is 3 and 4. That is correct. Most of you have got it right. Yeah, upper bound of 3 is 3 because 3 is greater than or equal to 3, and I mean lower bound of 3 is 3 and upper bound of 3 is 4. So that is right. So if you want to see for 7, the upper bound of 7 in this set. So it should be that no element larger than 7 is present in the set. Yeah, no element larger than 7 is present in the set. Now the next function is clear. It just clears all the elements of the set, and the set becomes empty after using this function. So here the set size should be 0. The upper bound of 7 would not be 7 because upper bound is it's supposed to be the first element which is greater than like whatever is passed. But there was no element greater than 7. The lower bound of 7 would have been 7. The upper bound, it does not exist. I mean, it'll return st.end. And why we use not equal to st.end during traversal? Because initially it is st.begin, and we want to print all the elements of the set. So we keep incrementing it and printing the value until it is not equal to st.end, because st.end is the theoretical position after the last element of the set, right? So in this way, it goes till the last element of the set, and after that only it fails this condition. That's why we put it is not equal to st.end. When this condition, when it is equal to st.end, we come out of the for loop. Yeah, so here st.size is 0 because we have just cleared it here. One more thing, you can, by default, a set stores all the elements in the ascending order. If you want to store it in the descending order, you can just write this here, and now it will store it in the descending order. Have I printed it? Yeah. Yeah, 10, 7, 4, 3, 1. Now it's in the descending order by just adding this much. Okay, anyways, let's. Oh yeah, there's a heavy spoiler in the next slide. So if you've not seen the Book of Boba Fett, the latest episode which released just yesterday, then I guess you can close your eyes and ears for some time. So this is again regarding the auto keyword itself. Instead of using the whole syntax, you can just use the auto keyword. So this is how you can print a set instead of this way. Let me just actually show it to you. Instead of this whole thing, you can just write for auto it. This is the range-based loop which Ishan taught you earlier. You can just do this much. Yeah, so this also prints all the elements. So this is how you can use the auto keyword and range-based loop to simplify your code and write less code. Yeah, so that was about it. So if you have seen the episode which released yesterday, you know what Grogu chooses. So that was the point. Anyways, you can use unordered set also if you don't want to store the elements in a sorted order, but this is not recommended usually because the time complexity can go up to O of n square in some cases, and it's kind of unpredictable sometimes. So for now, you can just use set always. The next data structure is maps. Maps are associative containers that store elements in a mapped fashion. Each element in a map has the key value and the mapped value. So here also begin and end are the same as before. Size is also the same as before. Empty is also the same as before. Insert. Okay, this function is this one way to insert elements into a map. There's one more way also. So there's one way, insert, and the argument should be a pair, and the pair should contain the key value first, and then after that the mapped value. Erase can take an argument of type iterator of the map, and it removes the element at the position pointed by the iterator, or also you can pass a key value inside this, and it removes the key value from the map. And clear is again the same, it removes all the elements from the map. Let's check all these functions. So here I've made a map of which has the key value of type int and also the mapped value of type int. These can be anything actually, even for set and for the previous data structures also, this can be anything. So here also it can be like string, comma, int. So the key value can be string or a char also, or anything actually. So for this example, I'm taking int and int. That is the key value is also int and the mapped value is also int. And here, like the insert function which I explained, you can use it to add an element to the map. So here I've added 2, 5. So in this statement, I've added a key value 2 and its mapped value is 5 using this statement. And here I've done mp1 of 7 is equal to 1. So key value 7, mapped value 1. And you can also perform operations like this, like incrementing, decrementing, and other stuff, even when that key value is not already present in the map. So like here I've done mp1 of 3 plus plus, but this is the first time I'm putting 3, right? Because I've not done it before. So here the default mapped value will be taken as 0. So that is the map element will be 3, 0. And when I do this, it gets incremented by 1. And when I do this again, it again gets incremented by 1. So if I want to check mp1 of 3 and mp1 of 2, like if I want to check the mapped value of 3 and the mapped value of the key value 2, I can just print it like this, mp1 of 3 and mp1 of 2. So what do you think the output is going to be? You can write it in the chat. 2, 5. 2, 5. Okay. Okay, mp1 of 3 is 2, mp1 of 2 is 5. Okay, 3 people have written it. 4 answers. Yeah. Yeah, that is right. That is correct. It is 2 and 5 because mp1 of 3 was initially 0 and then I've incremented it twice, so it becomes 2. And here I've directly inserted 2, 5, so mp1 of 2 is 5. So yeah, that was right. Okay, I've made another map which is of type string, int. The key value has type string and the mapped value is again int only. So I can keep a key value of anything. Like, so I'm here I'm doing mp2 of cheese is equal to 1, mp2 of string salsa is equal to 2. So like this I can do anything. Like I can even do mp2 of salsa is equal to perfect. So I hope you know what this means. This just a shorthand operator. This whole statement is basically MP2 of salsa is equal to MP2 of salsa plus MP2 of cheese. So again here, you can write the output of MP2 of salsa, maybe. Let's see who gets it first. Akash says 3. Yeah, okay. You're all right. It is 3 because MP2 of salsa was 2, and then we're doing 2 plus 1, so it is 3. Now here again, if you want to traverse through all the elements of a map, we can again use the auto keyword. And okay, since each element of a map is a pair, okay, it's a pair. So this is how you get the value of the first element and the second element of a pair. So this is again a range-based for loop, right? How to print value of key? Yeah, that's what. IT. So here in each iteration, IT is an element of MP1, right? And each element is a pair. So how do you access the elements of a pair? The first element of a pair, you can just write dot first, and the second element dot second. So here, this whole function, I mean, this whole for loop is going to print all the elements of a map. It's going to print the key value and the mapped value, and then it'll go to the next element. It'll print the key value and the mapped value. So this is how you can print it. Yeah, this is for MP1, by the way. I've done it for MP1. So it prints 2, 5, 3, 2, 7, 1. So yeah, 2, 5, and for 3 it is 2, and for 7 it is 1. Okay, so one thing to observe here, which is important, is the key values 2, 3, 7. Just like in sets, all the values are unique and sorted. In a map, the key values are unique and sorted. So here, as you can see, 2, 3, 7 are sorted on their own, even though I put 2 first and then 7 and then 3, but it's 2, 3, 7, it gets sorted on its own. So this was one important thing to remember. Yeah, that's what I've written here. In maps, the keys are unique and sorted, just like how the values in a set are unique and sorted. There's also unordered map, just like unordered set, which is again not recommended because it uses hash map, and the time complexity can go to O of n square, especially for big prime numbers. So you can just read about it if you want to, but you don't need to use it at this level. And I've left a few more links here if you want to read about all these in more detail. And that's it from my side. I'll hand it over to Ankur now. If you have any doubts, you can you please print MP2? Okay. MP2. Yeah, cheese 1, salsa 3. Cool. Yeah. Okay, range-based loops, right? So the auto keyword is, you know, the auto keyword, right? We've explained it before. It deduces the data type automatically. And basically in a loop, if you use this colon and a variable after this, like a map or a set or a vector, then what this does is, I mean, it's kind of a syntax itself, like for auto IT colon and then any variable name which is a map or a set or a vector. Then what it does is it IT it's just equivalent to this. It's just kind of equivalent to this whole thing. So what it does is it travels through all the elements of a map from the first element to the last element. Same for vectors and sets also. When you do this, it just traverses through all the elements of whatever variable you have put here. So it's just that. Yeah. So yeah, that's it from my side. Now I'll hand it over to Ankur. Where-
So hello guys, lots of knowledge about SQL for you all. Now let us move to the next topic, object-oriented programming. All you have learned till right now is procedural programming, writing logics, codes, and just performing the tasks without noticing the clarity and the efficiency of the program. So next thing we will learn is object-oriented programming. So what is OOP? So OOP is about creating objects and data that contains both data and functions. In object-oriented programming, we will work with classes, objects, properties, and methods. So what I mean by OOPs is can be explained using this name. Switching from procedural programming to object-oriented programming be like. So you have seen the difference. So So let me explain why we will prefer OOP over procedural programming. It makes the code easier to maintain and modify. It is also good for debugging, provides clear structure for programs, less code, short development time, fast and easier to execute. While writing long codes or while making libraries, we use OOPs only. C++ is all OOPs based. So now let's move. What are classes and objects in OOP? So classes is user-defined data type, which holds its own data members and member functions, which can be accessed inside or outside the class. A C++ class like is a blueprint for an object. You can think that a class is like a data type. When it is defined, no memory is allocated to it. And object is like its instance. Whenever it is defined, some memory is allocated to it according to the class. So you can understand the relationship between classes and objects with this meme. So now let's move forward. So what are classes? So classes have mainly three parts: access specifier, data members, and member functions. Data members are just the variables that are declared in the class, and access specifier and member functions we will discuss in the next few slides. So first we will discuss about access modifiers. So access modifiers are used to implement an important aspect in object-oriented programming known as data hiding. So there are three types of access modifier: private, public, or protected. Private members can be only accessed within the class. Public members can be accessed within or outside the class, and protected members can be accessed in another class with the help of friend function. I'll tell you about all three these while we are working in IDE. So we'll move forward. Class methods. So there are two ways of declaring a member function: inside the class or outside the class. You can see here we have declared the entire function inside the class, whereas here we have declared the function, but we have extended the class here, and we have write the whole code outside. This is done so because I have told you that in OOPS we want to make our code cleaner. So writing very huge functions inside this class will make it look weird. So let's move forward. There are two other functions inside this that are constructors and destructors. So they both are very special type of class members. One is called whenever the object is initiated, that is constructor, and destructor is called whenever the scope of objects end. So constructor can be parameterized or non-parameterized, And destructor, they both have same name, that of class, whereas destructors have a tilde sign before the name. So let's move to the IDE and understand it better way. So I am declaring a class here, class. Let's name it basket. And note, we should put a semicolon whenever we declare a class. Otherwise, you will get an error, and it's a very common error while you will get while you will working with classes. So next, let's give a access modifier named public and define a function named count, which will not return anything to us. Rather, it will tell us the number of items in the basket. Currently, I am just telling, I am printing that there are no items. Now we will declare an object for the class basket. Let's name it basket2, but for a smaller b. And let us now call this function here. See, there are no items. So this is how public works. We could access the count function outside the class. Now let us discuss about private. What does private hides? So let me declare two variables, name items in the basket, in the private modifier, under the private modifier, and a random variable inside public. So I'll show you that whenever we are trying to access the private member of this class basket, you will get an error that items is private within in context. So this tells us the concept of data hiding inside the oops. So we don't want that items to be visible or accessible outside this class, outside the class. So it is not accessible. And you can see that random is accessible. No errors. One is printed. So this is all about private and public. Now let us move to learn about protected. So what is protected? Now think of a class named a mall. So these baskets are within a mall, and there are trolleys also within the mall. So what you need to do is, mall has a specific criteria that every item holding every container like basket or trolley should have specific variables like object ID of the basket or trolley, the weight it can carry, etc. So rather than defining it again and again, we will create a class name mall, put a semicolon, make some protected members like object ID. We should not declare it anything, and another weight. I'm declaring it constant here because I'm working with baskets only, and this is how you will extend this mall into the basket. So you will have to first give the access modifier again here. I'm giving protected, then mall because I am accessing protected members. There are also, you can give a public here also, and it will the protected members will be protected here. I'll tell you all about this while we will talk about inheritance. This is the next topic after this ID part. So now you can see we will declare two functions. Name getter. Let me set this value. Void set ID. It will take an integer and set the object ID to this integer. And another function named print ID, which will print the ID of this basket. Basket ID is so let us set the ID to some random variable. Let me 12 and just print it ID. See, basket ID is 12. You cannot access it outside this class. Now let me tell you. Let's go basket object ID. So you are getting an error that object ID is protected within this context. So this is how protected works. Now you have learnt about access modifiers. If you have any doubt, you can ask in the chat box. And now let me move forward to let me tell you about constructors here. So now I am declaring. I have told you that constructors have same name as that of class, and we do not. It does not have any data type here because it is always void. Because it does not return anything. It's just called whenever the basket is initiated. I mean, the object is initiated. So this is the function, and what it will do is it will print basket sheeted. See, it is printing that basket is initiated. Okay. Now there is another way of declaring a constructor, that is passing some value. Now I'll pass some value and I'll store it inside these items, and I'll pass it here. So tell me whether we will get an error or not, because I am declaring this function twice. Anybody? So I'll tell you the answer. No, you will not get the error. The reason is because they are following a property named as polymorphism. I'll tell you in the next few slides about it. So let me print the value. Okay, I'm sorry. I have to pass it here. See, okay, I forgot to print the items. There are items. See, there are 10 items. So we have passed the parameter to this basket, and the items value is changed. So that is how this works. This constructor works. Now let me tell you about destructors. This also have same name that of a class, preceding with a tilde sign, and it is called after the scope of objects end. the dot count, then let's see what happens. See, uh, the basket scope is ended is printed 6 times. Okay, 5 times whenever this basket value is initiated, this object is initiated, and the scope is ended within this curly braces. So 5 times this is printed, and the last one is for this basket. Whenever the integer main int scope ends, this is printed. So this is all about constructor, destructors, and classes. So let us move to PPT. If you have any doubt, you can ask in the chat box. Okay, no doubts. Nice. So let's move forward. So here is name for you all. So next two terms that we are going to learn, they have weird names, but you should not have to memorize those names. You just have to memorize their understandings. You should have their basic understandings of what the words means. So by this means you must have learned that our next topic will be inheritance. So let us move. So inheritance is about accessing a base class inside the derived class. So I have if you remember, I have told you in the example that we are accessing this class small inside this basket, and I'll tell you about it while we are talking about inheritance. So here it comes. So the way of inheriting a class is, first we have to declare the base class before the derived class. Then while writing the syntax of the derived class, you have to put a semicolon, access specifier, and then the name of the base class. Okay. So the whole context of this small, it will be inside this basket. But what does access modifier here means is not that if you write protected, the protected ones are only accessed. They have a specific meanings. So you can see the table here. While working with the classes, while working with inheritance, if you ever stuck here with some errors, you must see this table. So public members, private members, and protected members, we are talking about under the class small or the base class, and the inheritance type is here. So whenever it is public, the public members of this class small or the base class is accessible as public. The protected members remains protected, and the private members are not accessible to this basket class. So we can hide private members of this small while putting an access specifier here of public. Next is private. Now, while we put private, all the members of all the functions of this class small or the base class is accessible to this basket as private. Okay, so all public and protected all becomes private here. And while we are writing protected, public members and protected members remains protected, whereas private members are also accessible as private members of this basket class. Okay. So next is polymorphism. You can see this is definition. C++ polymorphism means that a call to a member function which will cause a different function to be executed depending on the type of object that invokes the function. Leave the definition. We will discuss how it works. So see, I have told you that we are declaring basket twice, but still we are not getting error. This is because of polymorphism. So what this polymorphism does, it says that the basket, when we define a function, it does not only contain the data type and the name of the function, it also takes parameter inputs in its definition. So these both have different definitions. So while we are calling them, we are not getting any error. Next topic is overloading. So while C++ allows you to specify more than one definition for a function name. So if you give the same name and the same number of parameter outputs, still they can be differed by the data types of the parameters that are passed. This is overloading. The basic difference between overloading and polymorphism is the polymorphism takes the different number of outputs into account, the different number of parameters into account, whereas overloading checks the different types of data types that are passed. Okay. Next thing is encapsulation. As the name suggests, encapsulation binds together data functions and data. So it's based on the concept of data hiding. So I have told you that we have the private member here, and we will not be able to access it outside this basket class while we are working with code. Okay. So we declare two functions here: set items and get items, which can set the value of items, and we can return the value of items also. But the items is not accessible outside this class. This is encapsulation. This function, the setting function is named as setters, and the get items functions are getters. Now let us talk about abstraction. So abstraction is just about displaying the information to the user, but not the not the coder or not anyone will be able to access it. So see, we have declared the class small, and we have the object ID here. Okay. So we were setting it and we were printing it, but we were not returning it, or it was not also accessible outside this class. See, so we will not get the value while working with the code. We can only set it. See, this is the abstraction. The difference between abstraction and encapsulation is, in encapsulation we can get the value of items, whereas in abstraction there is no value. You can just provide the value in the interface. So this is the whole concept of OOPS. So now let's move forward. I know that many of you will be tired, but still we have a small topic ahead. I'll tell you, it will not take me much time, and it is important also. So it is common errors that you can get while working with the code. Many of you were told that you were Python programmers, then you must have gone through the errors of indentation errors. So while learning while learning C++, you can avoid these errors, but still we have some errors. Syntax errors. First are syntax errors. So the C++ syntax has few rules. You cannot violate them. First, and the two main important are putting a semicolon after every function, after every line, and the curly braces should be in pair. Okay. So if you avoid any of these, you will get an error like this. Next is runtime error. So runtime error are usually while you are executing a program. So this error is very difficult to debug because you will not get any output, and your program will crash. So you cannot debug it easily. One of the most common is division by zero. Another one you can get is infinite loop. So in both these your program will crash without any info. The other errors are logical errors that you can get when you will write a wrong logic and you will not get a desired output. Next one is linker errors. These errors are now avoidable because when you are using IDE, the IDE can tell you that the error you have written a wrong syntax, or you have written incorrect header files, and these errors are now avoidable very easily. But still, if you put some errors like put m capital of main function, then you will get an error like this. Finally, semantic errors. So semantic errors are when the statements written in program are not meaningful to the compiler. Okay. So see here, a plus b is equal to c. So these errors are very rare. You will not get these errors very easily, but still you should remember that these you should avoid these errors. So finally, task time. Let me show you the task. So here, you have to go to this repository. We will give you the link in the chat box. So what you have to do is, you have to go to this repository. You have to fork it, okay? And whenever you fork, you will be redirected to a new page where your username will be here, and Multiverse CPP is written. After that, you have to go to Replit. Just sign in with your GitHub ID, and you will see your GitHub repos here. So select this repo. It will automatically open up for you. So in our SRC folder, we have two tasks, task 1 and task 2. So you must go through these tasks and then write the main code in this task.cpp. So it has a main function. You will uncomment these lines and take the input from yourself and solve the task. You have to write into your main code inside the solve function, which will take integer and vector string ARR in the input, and it will return an answer. Just write your code inside this comment lines and do not touch this function. Okay. And while you need to test, just comment whole main function and uncomment this line. Go to shell and type make. So currently I am getting an error of unused parameters and fail. See, I have not written anything. I have just returned the answer 0. So I have failed all the test cases. Okay. When you will write code here and submit it, if your answer will correct, and you will get a success status here. Another task is inside this task 2 folder. So here you have to construct a class, and all the methods are written. What you have to do, just follow them and write what is written in that. You have to complete this task 1, task 2 and task 3 functions. You have to complete this function and you have to write a constructor here also. Okay. And when you will complete it, just repeat the same thing, comment this main function, uncomment the last line and type make. Note that task 2 will only be judged after task 1 is completed. Okay. So this is how you will work. And in the learn folder, we will keep all our files that we have teached, class, SQL, and about file handling, etc. All will be here. And note that if you want to run this file task.2.cpp using this, so what you need to do is go to this replit. Okay. First, see the path here, src task2.cpp. You just need to do is type it here, src task2 slash task2.cpp. Okay. Now you will be able to run it like this. See, I have not given any output, so it is not returning anything, but it is executed. You can see the path, source task2.cpp. That's how you have to do the task. So thank you all. And still we have a deadline of 17th Feb. You must do the task before it and create a pull request. I will show you how to create a pull request. Go to version control, create a new branch, type your commit and push it. Then when you will come here, you will get a message of pull request, creating a pull request. Just create a pull request from here and your code will automatically be judged. You can see that we have 2 pull requests. If your code is correct, you will have a tick sign here, otherwise cross. Okay. Yes, while submitting, you must uncomment the last line and comment the main function. Otherwise, you will get an error. Okay, just uncomment this and comment this main function. Now you can complete your tasks. Thanks. If you have any queries, you can ask me in the chat box or you can contact us. Yes, yes, you can do it in VS Code also. Just clone it. You can read this README here. It has all the method to do so. Just clone it. Go into this folder and write and go to task1.cpp. If you use code runner extension, just run the code from that. And while submitting, you have to just follow the same procedure. Uncomment the last line, comment the main function, and type make in the terminal and press enter. It will check. Any other doubts? Type the make, just comment the main function and uncomment the last line and type test make. It will test. So that's all. If you have any doubts, you can ask us. Thank you.